Hi, today we're going to talk about Cisco's Unified Communications products as well as their unified computing systems. So what we usually refer to this as UC on UCS. So from a very basic, simple standpoint, we start off with what we traditionally have on our networks. So a lot of folks have basically an isolated voice solution. So they'll have a voice network, which may be a traditional PBX, phones, voicemail, fax machines, and so forth. Then they'll also have a standalone data network. Now that's how you get to the internet. That's where we plug our PCs, our laptops, and our printers, and any other network devices that we might have. And finally, we'll have a video network. The video networking has traditionally been mostly just video conferencing, but now with a lot of the advent of peer-to-peer networking like Skype and other products, webcam services, WebEx, things that are going to be using video, this video network has become a pretty busy little place as well. Well, one of the things that we don't enjoy doing is managing each of these networks in an isolated standpoint. So one of the things that Cisco has really worked on doing is taking all of these and combining them in one. With our data network, we have switches. The switches is what pretty much everything is being plugged into. So our PCs are plugged in, our laptops are plugged in, and our printers are plugged in. Well, one of the things that Cisco's done with their unified communications is, from a voice perspective, they've just taken these devices, which were traditionally on a big, huge box, with the phones running on proprietary cable and voicemail being plugged in, and they've broken that out into specialized services. So we may have a lot of these phones, but now voicemail is simply on a server, which is then plugged into our data network. Our PBX, which is basically all our data handling for our voice calls, so anything associated with actually making the call and so forth, and whatever we talk to the phone company with, that's on a server. And those plug in. And then they took these individual phones, they gave each of the phones themselves a network connection rather than a proprietary connection, and those are plugging into our data network. So now we've really combined our voice and data network. Well, then they've gone and done the same exact thing with the video services. With the webcams, the peer-to-peer, the video conferencing equipment, we've broken these out to where the web services and peer-to-peer that we're running on top of our PCs are still able to do that, but we're able to control them. And so I'll represent that by showing that we're still using the same network connection for our video, but we're still using it directly connected to our switching and a direct connection to our data network. And then from a video conferencing, they've got the high definition video conferencing is on a codec, which is basically like a little server in and of itself, and once again, that video plugs directly into the network. So what we've essentially done is take three disparate networks and combine them into a single network. This single network is now able to have a lot of other properties that Cisco has built into it, like quality of service, which we like to call QoS. They have VLANs, which are basically separate networks from a logical standpoint rather than a physical standpoint. And then they combine that with the traditional data routing to be able to move things around. So what we've actually been able to do now then is we've been able to say, you know what, voice is very, very sensitive to coming in, getting priority and so forth. So we'll give it priority 1. We'll give video priority 2, and we'll give data priority 3. And so when you're having a voice conversation, if you miss a couple of packets, if you drop a couple of things, you need all the words. You can't just get most of the words coming through. So it's really important that voice goes through every single time exactly the way you expect it to. Video's a little more forgiving. The eyes are a little more forgiving than the ears. So just like with TV, the quality levels may or may not be as good as a still shot, but because it's a moving shot, you've got a little bit better ability to be able to not have a perfect situation. And with data, by design, the data network has been built so that if certain packets or certain pieces of information don't make it there, they're automatically resent, and they'll all get there in the end. So what we've really done is we've taken everything and we've combined it all into this single network, and we'll apply quality of services like we've discussed here. We'll apply virtual LANs, so we'll basically call this LAN number 1, LAN number 2, LAN number 3, and we'll qualify it from a quality of service level. And now we have a central product line, one set of products that we're managing, and we can use the same standardized tools rather than all of these different product lines all being on their own, all without being able to communicate. The other thing that this adds to is it allows my PC to have direct access to my video and even have what they call soft phones, a phone that's actually on my PC, and so forth. So the combination of all of these services now become available, which makes things like WebEx and other collaboration products very, very viable. So once we've done this, we still are in a situation where a lot of times we'll end up with a pretty large number of servers. So we'll have servers now for the voicemail, we'll have servers for the PBX, we'll have servers for our data network, for all of the servers, all the services and so forth that we typically deal with already. Video may have its own proprietary servers, and so we can really end up, once again, with kind of a large amount of disparate boxes. So we'll have all of these different servers basically in this situation, and we need a way to manage those. So that brings us from the UC, which is the Unified Communications, over to the UCS. UCS is essentially the same idea. We're going to take a lot of these products and we're going to combine them and find better ways to manage them. So, for example, I'm going to erase this part right here since we pretty much know what our network looks like now, and I'm going to talk about these servers. So what Cisco's done is they've taken a single box and created a blade server scenario to where essentially you have multiple servers in a single box. Now this isn't a brand new invention, but Cisco has really added a lot of features to this design in order to be able to, once again, centrally manage, easier to deploy, easier to overall take care of, back up, and so forth. So what they've done is they've designed this with virtualization in mind, and virtualization, basically, a simplification is one physical box can run a virtual server, and each of these physical boxes are running an operating system and an application. Well, I can take all of those applications and I can put them in a virtual world so that maybe 3 or 4 of these servers are being run on a single physical box. So let's look at it from that angle. So let's say I take these 3 servers and I virtualize them and I combine them into this blade. And I take these 2 and I combine them and put them into this blade. And I combine these 2 and put it into this blade. So what I've done basically now is I've shrunk a large amount of equipment. What this ends up doing is it allows you to be able to reduce the total amount of power you're using, reduce the total amount of cooling, and reduce the amount of space that you're keeping, which in and of itself is a cost savings. In addition to that, we can take additional services and additional parts and pieces that we need to be able to add in, like our video server, our voice products, and run those on these blades. Now, that puts some pressure on this box to be extremely well managed. And one of the things that Cisco has done is they've added an additional box called a Fabric Interconnect. And out of this, you get multiple high-speed, redundant connections going to the Fabric Interconnect. The Fabric Interconnect itself is allowing multiple converging technologies like fiber channel and your Ethernet networking and what is now being referred to as fiber channel over Ethernet, all to be plugged in using a single cable, which definitely cleans up what this traditionally will look like, into a single cable and a box that's able to actually break out that technology as necessary. In addition, this has got a smart head in it, in that it actually is able to manage a lot of the information on these servers. So these servers themselves have a lot of proprietary information associated with them. The processor that's in them, the network card that's in them, the motherboard, all these different components have a lot of uniqueness. So in a traditional standpoint, even if I have a great service level agreement on this server, if this server dies and I replace it with another exactly the same server, it's still a bit of effort put that operating system and the applications back on it with even with a backup recovery process, because once you bring the system back up, it's going to say, hey, this is not exactly the same server, and it's going to ask you for things. You may have to re-register your software, the software keys that are in the back may not work, and so forth. Well, what Cisco's done is it's basically allowed you to create profiles. These profiles are then stored on this Fabric Interconnect. And if this box and all the uniqueness associated with it dies, I get a new blade that comes in, or maybe I even have a spare blade right here. Either way, I'm basically going to want to take that physical essence that was here and put it somewhere else. I'm able to basically take the profile, push it down to an additional server, and within 10 minutes that server is essentially exactly the same as this server was. Restore my application, I'm back up and running. And in addition to that, if I grow outside of this box, and I end up having another blade server, I'm able to continue to manage this with one management platform and push across boxes. That's something you're not going to see with your other vendors. They're going to have a blade server, but that blade server is still not going to have any ability to talk to another blade server or have any additional bonuses by moving these things together. So overall, what we're able to do is we're able to save on space, power, cooling. We're able to save time by creating profiles. We're able to save cabling, which again, I guarantee if you walk into most computer rooms, there's a lot more cable than you would really like to see, or the front of the switch has got cable strolling down. So we're going to save on cable. So it makes it much easier to be able to troubleshoot which cable goes where, not accidentally knock things off. We're going to save on the way that we manage, because we're going to be managing, remember, all of our different products on one backbone. And overall, we're able to take all of these products and utilize them with less tools, with less management, and less space. The last thing I want to discuss is, so originally we discussed UC, we also discussed UCS. Well, one of the things that AtNet brings to the table with Cisco is we're capable of handling all of your UC issues. We're capable of handling all your UCS, but then we also are able to take care of all of these servers from a storage standpoint. So you may have a traditional company like EMC or NetApp that actually provide all of the storage information that you have for your backups, for replication, for disaster recovery. And I can take these blade servers and plug them directly out of the Fabric Interconnect into my, my SAN. So now all of these blades have access to the same storage. All of these blades can have access to the same storage. And once again, we've consolidated. Instead of having all of these servers with their own hard drives and so forth, I've been able to take a small number of servers with a large number of virtual servers on it, give them a central access point. So now it makes my backups easier, it makes performance easier. I'm able to manage a lot of the pieces and parts of where my data goes and how I want to get it there and what's the most important, how to archive it and so forth, much easier. So AtNet's able to bring to the table both executing Cisco's plan as well as adding in the third-party vendors that are necessary to be able to complete this entire picture, and again, give you a better sense of where you are, what you want to do, and how you want to get there, and save across the board, no matter how you look at the design.